Hello everyone, welcome to my YouTube channel Basic Engineering Mathematics. In this video, we will explore Cauchy Euler Homogeneous Differential Equation. So, an equation of the form x power n d n y upon dxn and plus a1 x power n minus 1 d n minus 1 y upon d x power n minus 1 and plus a2 x power n minus 2 d n minus 2 y upon dx n minus 2 and plus up to a and y is equals to q. So this equation is known as Euler-Cauchy equation or Cauchy's homogeneous linear differential equation. Here a1, a2, a3 up to an all are constant and q is a function of x. So this equation can be reduced to linear differential equation with constant coefficient by using the transformation x is equals to e power z or z is equals to log x. So we have to follow some steps to find the solution of Cauchy-Euler form equation. So first step is we have to put x is equals to e power z. So z is equals to log x and let us assume that capital D is equivalent to d by dz. Now in second step replace x d by dx by d x square d2 upon dx square by d minus 1 and x cube d cube upon dx cube by d minus 1 d minus 2 and so on. So after putting these values, the equation will be reduced to linear differential equation with constant coefficient. And this kind of differential equation we have already discussed in previous videos. So for example, we have to solve the equation x square d2y upon dx square and minus 2x dy by dx minus 4y is equals to x power 4. So this equation is in the form of Cauchy-Euler equation. So we have to put x is equals to e power z and x dy by dx is equivalent to capital D y and x square d2y upon dx square is equivalent to d minus 1 y in the given equation. So given equation will be d minus 1 and minus 2d minus 4 into y is equals to e power 4z. Since in given equation function q is equals to x power 4. And after applying the transformation, x is equals to e power z, x power 4 is equals to e power 4z. So now simplify this equation. So equation will be d square minus 3d minus 4 into y is equals to e power 4z. So this equation is linear differential equation with constant coefficient. So solution of this equation is y is equals to complementary function plus particular integral. So firstly, we have to find complementary function. So for complementary function, the function e power 4z assume equals to 0. Now find the auxiliary equation by replacing capital D by m and y by 1. So auxiliary equation is m square minus 3m minus 4 is equals to 0. So therefore the roots are minus 1 and 4. So both roots are real and distinct. So complementary function for real roots is equals to c1 e power minus z and plus c2 e power 4z. Here complementary function is the function of z because we already replaced the variable x in form of z. So now we have to find particular integral. Particular integral is equals to 1 upon fd into q. Here fd is equals to d square minus 3d minus 4 and function q is equals to e power 4z. So since the function q is in form of exponential function, so we have to replace capital D by 4. So after replacing D by 4, FD will be 0. So this is the failure case. So for failure case, we will multiply by Z in left side of operator and differentiate FD. So differentiation of FD is equals to 2D minus 3 and function Q e power 4z. Now again replace capital D by 4. So particular integral is equals to z by 5 e power 4z. So now the complete solution is y is equals to complementary function plus particular integral. Now put the value of complementary function and plus particular integral. So this solution is in form of variable z, but the given equation is in form of x variable. So solution should be in x variable form. So now put the value of z equals to log x in complete solution. So complete solution is c1 e power minus log x plus c2 e power 4 log x plus log x upon 5 e power 4 log x. We know that e power minus log x is equals to 1 upon x and e power 4 log x is equals to x power 4. So this is the required solution. Thank you all. If you like my video, then subscribe my channel.